Chief AI Officer from Data Foundry, Dr. Raj Ramesh, is going to talk about AI-driven transformation to business. That's going to be our last session in 10 minutes from now. Thanks a lot. Really appreciate it.
So it seems like most of them are towards somewhere just starting out. That's just good news because most companies are in that phase. So so that's good. Excellent.
All right.
So you all know now from each other how your neighbor is doing in terms of this journey. So you can seek comfort in the fact that nobody else is at the far end of the spectrum of having full-fledged AI adoption. When we talk about AI and transformation, there's three big things that I want to talk about. One is the people, two is the business, and the technology. I'll go about in this order, share some information here. We're not going to cover everything here, just some data points. When we talk about people, it's about the customers, employees, shareholders, and customers especially. What is their experience going to be like? On the business side, we'll just touch upon some operations and processes and maybe products. On the technology side, we'll talk about a little bit of AI and other technologies, maybe like, we won't talk about other technologies, but only touch upon AI. So, let's talk about the customer experience. I'll talk about, here's an example of very poor design. The first one says stop, and it says no stopping anytime. So, make up your mind, guys. Should I stop or not stop? Poor design. This morning, when I took a shower, I used this cologne, and if you look at that cologne, this nozzle at the top is very hard to read. I can't really figure out which side the nozzle is, and half the time when I spray it, it goes to whoever is standing next to me gets the spray. Luckily, it happens to be my wife, but still, she doesn't like men's cologne on her. So this is poor design again. How difficult would it be to just put up a small circle, white circle around it so I can recognize which side the nozzle is? These are poor product designs. So AI cannot fix these kinds of things. Here is another process problem. So I have some money in a big bank in India. Just to be clear, the money is not big, just the bank is big. But to get the money out, the branch manager tells me that I need an Aadhaar card. Now, but I'm not eligible for an Aadhaar card. That's what the government, the Unique ID Authority of India tells me because I am an NRI. So that's why you see me scratching my head in the middle. I need an Aadhaar card, but I cannot get one. This is a total process problem. Cannot be fixed by AI. It has to be fixed by humans before AI can even help here. So what are some of the business challenges? People think, especially leaders, think that AI somehow will come in and be the silver bullet and it will solve all the problems. Sometimes expectations are too high, we don't want to do prototyping, and there's a lot of politics and siloed organizations. So people don't want to share information. If you don't share information or data, then you can't really deploy a good AI solution within the context of the business. I'll give you a real example. You know what? The city of Flint had a water problem. The city of Flint is in Michigan in the US, and they had a lead problem. A lot of their pipes were, a lot of the houses were old houses, and they had lead in them, and lead is a known carcinogen. So the idea was, let's go to these houses and remove the lead pipes and replace them with copper ones. A group of machine learning experts got together and said, this is a great problem to tackle with machine learning. So what they did was they looked at the age of the house, value of the house, and location of the house, and there were 40,000 homes to inspect in the city of Flint. And they created a model where they could identify with high probability which homes did contain lead pipes. So when they went to inspect these homes, they had a 70% success rate because they identified, they went to specific homes only those that had a high probability of having lead, and they got a 70% hit rate. So it worked well, but what happened was halfway through the city switched to a different contractor with a $5 million contract. This new company, they came in and said, this machine learning, we don't want to do machine learning, we just want to inspect every house. And there was some political problem as well, because the councilman said that we cannot be unfair to the population, and we want to inspect everybody's house. So what happened was they ended up they tried to inspect everybody's house, but what happened was you ran out of $5 million pretty soon because it was not a focused effort. The point I'm trying to make is that even though there was a machine learning solution, politics got in the way, and the company did not really, and this was a total failure. You might have read about this in the news. Having said that, there are good applications of AI. There are a lot of places where AI helps. For example, in agriculture, we can increase food production because we can target specific plants on nutrition and water supply, and be focused. We have robots that take up dangerous work. We have automatic financial advisors now that take care of 80% of the general advice that people need. Diagnosis in tumor and heart disease is another AI application, because it can read radiographs at a high speed without having the surgeon or the doctor have to read all these, who gets tired by the end of the day, and so on. And you must have heard about Tesla and all those cars that are autonomous, that can drive itself. All this is possible because of different branches of AI, sometimes multiple branches of AI. So there's a lot of good things happening. The question is, how do you integrate it into the context of the whole enterprise? I particularly want to talk about one application, which is AI machine learning in healthcare, because I'm working in this area as well. If you look at drugs that come to the market, from the research phase out to commercialization, it usually takes about, in the US, takes 12 years to get out to the market, and it costs about $1 billion. The problem is there's a lot of structured and unstructured data that has to be processed. And there are a lot of participants in this whole ecosystem. Doctors and researchers and patients and medical companies and so on, who exchange all this information. Some of this is exchanged through paper, some of this is email, and some of it is structured in relational databases. But essentially there's too much, and the proportion of unstructured to structured is it's heavy on the unstructured side. So what happens is there's just too much information to handle. And machine learning and AI is a great technology to handle this. So what we try to do as a part of Data Foundry, which I'm the Chief AI Officer for, we are trying to build a platform that enables AI processing. And this is not easy to do. It is difficult, which is why it hasn't been done for a long, long time. But now that we have all these AI technologies, at least there is light at the end of the tunnel. Now since this is a security conference for most of you are security experts probably, let's talk a little bit about security. Cybersecurity Ventures says that there will be a shortage of 3.5 million cybersecurity workers by 2022. So how do you make this up? What can you do? This is where AI can help in some places. And here are some of the examples where AI can help. I'll talk about the red bullet point later. So we have, for example, we need to secure data. Data is getting on the cloud, and we need to secure data. That's a security issue. You must have heard about Capital One's recent breach. They had data on the cloud and it was breached. There is the problem of using illegal data for rating. So for example, in life insurance, if you already know, before a company gives out its life insurance, if you can run a machine learning algorithm to find out if this person has a higher probability of dying based on some personal characteristics, then it may not be willing to give insurance to this person. So it borders on being illegal at some point. So these are, even though it's not directly security, it is illegal use of information, which we have to worry about. And worrying about securing models itself, because the model that essentially captures the data is very critical. And once your competitor knows this model, they can use the same model for their purposes. Now, just because let's go back to the first bullet point, 99% security, accuracy. Just because I have a system that's 99% accurate, it may not be good enough. And instead of talking about it, I thought I would show you another video on credit card breaches on a system that can have good, high accuracy, but was not worth it. When 99.9% accuracy is not good enough, imagine that I'm trying to sell you a state-of-the-art machine learning system. This system, I claim, can predict the outcome of certain events with a 99.9% accuracy. Would you buy that? Before I answer that question, hit that subscribe button and click on the bell icon to be notified of new videos on architecture and AI that I share every other week. Apologize for that plug-in. So you are in charge of catching fraudulent credit card transactions. Say that there are billions of transactions that happen every day, and less than 0.1% are actually fraudulent. My machine learning system is pretty simple. For any transaction you feed it, it'll simply say not fraud. And it'll be right 99.9% of the time. But the problem is you still haven't caught any of the fraud. Real machine learning systems are trained on lots of data. And let's assume that this data has somehow been labeled as good and fraud. Here's a simple two-dimensional view of the data, but in reality, this is a multi-dimensional view that includes attributes like charge amount, time of the day it was charged, charge location, whether it was online or in person, and so on. The black points are indicators of good transactions, and the red points represent fraudulent transactions. Machine learning is good at generalization, not at finding anomalies. So we have to somehow bring some evenness to this kind of unbalanced data. There are many options here. We could try to find more fraudulent data or generate fraudulent data so that the clustering algorithms work better. We could try to resample the data to balance it out or even out the number of data points, so we have approximately the same number of data points in each of the classes. But you see how that data loss can skew the clusters. We could use a loss function for the machine learning model that imposes a much heavier penalty for incorrectly classified fraudulent transactions. This effectively reduces the size of the regions around the fraud because it's expensive to keep this region big. Or we could use a specific class of machine learning models called decision trees that essentially segment the feature space into blocks. No solution is perfect, and you might have to use a combination of multiple approaches to get overall good results. So don't fall for the machine learning system that is 99.9% accurate. If you enjoyed watching this video, please consider subscribing. Thank you. So don't fall for somebody who says this is 99.9% accurate. Let's talk, so far we've talked about the company, transforming a company. But what about you? Because AI is introduced into the organization, it is going to impact each one of us. So the questions we might have is, how do we adapt? Before I start on that, I have another survey that you might have to pull out your pads for. And This might have changed as well, maybe, but go with the old questions if you have it, and we'll just, if we can, spend some time to get that a response from the audience. That'd be great. Is that the results that I see? I think.
Is it visible to you? The results are visible to you, Raj?
Yeah, it's kind of visible. I can make it out. But what's the first bar that's high? Is that the first?
It says not afraid.
Oh, okay. That's great news. That's excellent news then.
All right.
So maybe most of the audience here are professional, have a strong technical leaning, or maybe a strong legal leaning, so we're not afraid. Excellent news.
All right.
So maybe the rest of this is not applicable for you, but I will go through it anyway. One option is you can take this option, which means it makes no sense to worry about the future, but by the time you get there, it's the past. This is the option that my teenager takes, and some of you might have who take the same option as well, not worrying about the future. So do you actually have to fear AI? A quick story, I have a friend, he's only studied up to 10th grade or 10th standard, and even that he failed. But now he runs a biotech company, and he has 6 PhDs reporting to him. So he's not necessarily the smartest guy in terms of academics, but he is the one who makes money for the company because he provides what the customer wants. And he is much more successful depending on how you measure success. You know, they say AIs are like these PhDs. They're very smart, but just because you have a bunch of them doesn't mean they can better humans. As an example, you put 2 PhDs in a room, you'll get 7 different ways of solving the problem. I know this. So the main thing I want to point out is, even though AI is smart, they're smart in very narrow regions, and you don't have to generally worry about it if you can understand that you don't mess with what it's smart in. As long as you can complement its strengths, then we're good. So basically, don't worry, but on the other hand, be prepared to position yourself in the right spot as in the future. And don't try to do the same things that an AI or machine learning system can do. So the basic approach for transforming yourself or oneself is the same. We understand where we are, we understand where we want to be, and figure out how to get there and where AI fits in this journey. We have adapted very well to computers, so none of us do, at work at least, we don't add numbers in accounting manually, we use computers to do that. So we have adapted to doing different things. Likewise, we need to do the same thing when AI comes into the future. So here are some bad advices that people give. Bad means useless, really. Well, when I was in 12th, one of my uncles used to say, "Hey man, get high marks in 12th, okay?" But the point is, that's very obvious. But how do you get that is the question. So I'm not going to say to you, just figure out the future, because that's useless information. I'm going to offer you another short video that says, how do you think about jobs of the future so that you can adapt to it? And here's one. This is a little bit longer, but stay with me on this. How to think about jobs and the future of work. In my book, AI and You, I introduce the concept of your ecosystem and share some tools to model it. Once you better understand your current ecosystem, then you can transform yourself to a future that you envision for yourself. The general philosophy of adapting to an AI future is to place yourself in a competitive position, just like what companies try to accomplish through business transformation. To set the foundation, let's assume that nobody can predict the future jobs with any degree of certainty. What we can do is to take educated guesses based on trends, on technology, and on the market, which is why it is important to understand the current environment, a lot of what I talk about in the book. To understand and frame the jobs of the future, we actually don't need to look at the jobs themselves, but instead look at individual tasks that make up the job. Thinking of tasks is much better because it is more granular and we can better predict if a task can be automated or not. Then we can put this all back together into the job to figure out how much of the job will be automated. For example, a cashier's job is to greet customers, scan items to be purchased, bag those items, accept payment from the customer, and close the purchase with a smile. Not all tasks are equal, which is why I drew them in different sizes. Some of these tasks have potential of being fully or partially automated. A doctor's job might include tasks like greeting the patient, listening to the patient's symptoms, scanning a medical history, asking probing questions, thinking through options, ordering additional tests, scanning test results, prescribing medicines, filling out paperwork, and a few more. So let's figure out if a task is a candidate for automation. I'm going to consider multiple dimensions here. The first is rather obvious, and that is technology. Over time, the levels of automation have changed due to technology. First, we had mechanical automation, like using big machines to help build roads. Then we had software-based automation, like using computers to control variables in a brewery. Then came data-based automation, like using data to make predictions about customer behaviors. And now we are exploring cognitive automation, like having machines read volumes of legal case histories to identify precedents. So we need to understand if we have the technology to automate the task. The next is predictability of the task. The more predictable the task is, the easier it is to automate. The predictability on some tasks are more clear-cut than others. For example, a police officer's task of giving a ticket is based on how fast over the speed limit you're driving, and that's easy. A cardiologist reading your ECG to identify any heart problems you might have is more nuanced. But we're getting to a point where machines perform better than humans in detecting cancers by reading images. Then next is a return on investment. On the cost versus value scale, companies will seek to automate tasks that get them the biggest bang for the buck. Cafeteria cooks, for example, can be automated, but it is cheaper to hire cooks to do the tasks anyway. On the other hand, consider knowledge workers who make up the majority of the workforce, do many of the tasks that could be automated, and also get paid a lot more than cooks. So that's an area where companies would look into and have incentive to automate with cognitive technologies like AI. The next dimension to think about is time frame. Even if automation of a particular task does not happen now, when will it happen? In 10 years, in 20 years, or much beyond? Of course, the further we go out into the future, the more unreliable will our predictions be. From a manager's point of view, maybe the task of managing projects will be automated in the next 10 years, but the task of motivating her team members will not be automated anytime in the next 30-year time horizon. Next is the customer acceptance. Even if a task is automatable, would the customer want it to be automated? Our experiences with automated call routing have taught us that most customers still like to talk to humans who can solve their problems much more quickly. Perhaps that'll change with better technologies. And in some cases, humans may still be wary of machines. Would you let a robot cut your hair? The next is explainability. Today, machines can process large volumes of data and identify patterns or reach conclusions. But humans still want to understand how the machine came to the conclusions that it did. So government regulations may be put in place to prevent some tasks from being automated. Maybe a judge still has to give the final sentencing, even though a machine may make a recommendation. Another thing to consider in task automation is the ecosystem support. Maybe the task of shelving products in a supermarket is not automatable today, but what if the supermarket reconfigures their shelves to make it easier to automate? Amazon, for example, reconfigured its warehouse for automation, which in turn reduced the number of forklift operators. While full automation may be decades away, many human tasks will disappear. Finally, there is task importance. There are some tasks that are considered important and cannot be delegated or automated. For example, a business should consider tasks like formulating its strategy, creating innovative business models, understanding how technology can enable the business, and so on, to be critical that it can be aided by automation, but will continue to require human ingenuity and innovation. By the way, how do we define a task? Here is some high-level guidance. Don't overthink it. If you feel like there is too much included, that you can't really think about these dimensions, then break up the task into smaller units. If you're getting too granular, that's okay to combine tasks. The important thing is to be able to understand the likelihood of automation of any task. Now that we have explored some dimensions for automation, what does this mean for your job? You have to do some research and thinking about how your job may be impacted by automation and specifically AI. Then think about all the tasks that your job requires. For any particular task, use the simple framework to explore the chances of it being automated and when. Repeat for each task. The time you spend on all the tasks are not equal. So get an idea of the amount of time you spend on each of these tasks and do a simple calculation to see what approximate percentage of your job might be automated soon. In the future, you want to have a job that has many non-automatable tasks. In your new role, there might be the same or modified versions of the tasks that you are currently doing. Also, you might want to add more tasks that require you to learn new skills. The non-automatable tasks could use your skills in the areas of leadership, communication, storytelling, empathy, creativity, problem-solving abilities, software development, analytics, design, and others. So pick tasks that have a high component of these. This is not a comprehensive list by any means though. Essentially, you can define a brand new role using a combination of tasks that bring out your skills, passion, interest, and your background, thereby making you unique with a competitive advantage and differentiated from what machines can do. Then you're off to a great start on self-transformation. The bottom line is this: think, transform, and thrive in an AI future. If you enjoyed watching this video, please consider subscribing. Thank you. So one of the things that I want to just mention is, though these may not be our problems for now because we are much older, and perhaps are all gone through the experiences that we have already gone through. We're not worried about it. I am personally worried a lot about my teenagers who will go out into this new AI world, and they have to figure out what is good for them and how to adapt in this future. Because when I studied, it was easy to either pick engineering or medicine as a choice, as the first two choices. But today, it might be possible that engineering or medicine, a lot of things will be automated even there. So we can't just say, just pick this career or the other. So that's where the complexity comes, and I hope we can use these ideas to help your kids and your grandkids adapt to the future. So we talked about how companies can adapt, we talked about how you can adapt and what is in the context of AI, and I essentially want to conclude with this statement, which is the world is changing and those who adapt have a better chance of a better future. Thank you, and open to questions.
Yeah, thank you, Raj. You're standing between them having a supper shortly, I guess. So, we can, Raj, any questions for Raj? Any questions for him? Of course, he's got his email ID as well. And if you have any questions also, you can go ahead and share your questions with him. If you don't have any questions for him, thank you, Raj. I really appreciate your time. I don't know which time zone you're in. Could I ask which time zone you're in?
Yeah, in US Central, it's about 7:30 now, I guess.
Oh, all right. So you should have woken up pretty early in the morning, I guess. Yeah. Thanks a lot. Really appreciate you waking up early for this session. So we'll let you go. Enjoy your workday, I guess. And we'll let our delegates leave for the evening as well, or whatever is left for them.
Sure.
All right.
It was my pleasure. Thank you very much.
Thank you, Raj.
For the opportunity.
Yeah,
Bye.
thank you. The feedback for this session. Yeah. Sorry. Hang on, guys. Hang on. The feedback for this session.